All right, good morning. Well, it's morning right now when I'm doing this lesson. Uh, Starting our next lesson, we have two more lessons before our next test, and I think our next test will be this Friday. We are going to focus this one on isosceles and equilateral triangles. First one I want you to really get yourself acquainted with or to know is the isosceles triangle. Okay. By definition, isosceles has two congruent sides. Those two sides are equal. Please pay attention to those markings. Okay? So now that we know this, let's go into a little bit further detail of the parts of an isosceles triangle. Okay, so we're just learning that an isosceles triangle has two congruent sides. Those are called legs. So in this case, we have this side right here. So you can easily write AB is congruent or equal to BC. Now, next piece of an isosceles triangle, the angle where the legs intersect is called the vertex angle. Where those two sides meet, that's this angle right here. That is called the vertex angle. So in this case, the vertex angle is angle 1. Then you have the side that is opposite. So you have the two sides that are equal, and then you have, because it's a triangle, you have that third side. That guy will always be opposite the vertex angle. He will be called the base. This side right here. He is the base. AC. All right, last part of an isosceles triangle is the two angles that are at the bottom. Notice how we pointed out the vertex angle, but then we have the two angles right here. Angle 3. These guys are called base angles. Okay, so those are the parts. We're going to use these parts, and it's going to help. It's going to be the most useful in the algebra problems you're going to be doing in a minute. All right, so the first theorem, and remember, converse is always just the backwards of the original theorem. So if we're looking at this first isosceles triangle theorem, it says if two sides of a triangle are congruent, then that means that the angles or the base angles opposite sides are congruent. How do I write this using that triangle that's up there? So I put if AB is congruent to BC, then angle A is congruent or equal to angle C. That's all it's saying. If it's an isosceles triangle, if two sides are equal, that means that the two base angles are equal. The converse, it's just the backwards. it says if you have two base angles that are equal, then the sides have to be equal as well. So if angle A is equal to or congruent to angle C, then the sides are congruent. You have AB is congruent to BC. All I did was rewrite this sentence backwards. All right, so now we're going to apply this information. Okay, these are just isosceles. That means two sides are equal. That means two angles are equal. So a lot of this stuff will be easy. Always pay attention to these marks. Okay, two sides equal. That means this is isosceles. So if two sides are equal, that means the two angles have to also be equal. So angle J is 68 degrees. If I want to find angle K up here, well, that's just 180 minus 68 minus 68. 44 degrees. Another example. Here we have okay, so we have the two sides that are equal. That means that these two are also equal. All right, how do I find both of those angles? If we know they are equal, then I know the triangle has 180 degrees. If I take 106, okay, I'm left with 74 degrees between both. If equal, simply divide by 2. 74 divided by 2 is equal to 37 degrees. Okay. All right. So this uses the converse. If two base angles are equal, then the two sides are equal. Here's base angle 1, here's base angle 2. That means this one and this one are both equal. This side is 12. That means y to z is 12. How do I find the vertex? 180 minus the two base angles. 26 degrees. All right, let's look at, now that we took algebra back in here, let's look at, let's see, solve each variable. Okay. Here we have number 7. We have 2 base angles equal. So 2 sides are equal. Right into the algebraic equation. 9x minus 73 equals 3x plus 23. Move the 3x across by subtracting it, so you get 6x minus 73 equals 23. Then we move the 73 across by adding it to both sides. And you get 6x is equal to 96. And the last one is division. X is equal to 16. And that's all they want. They just want the variable. All right, let's move on. Let's do one more. I want to show you one more example. 8, 9, and 10. I'm going to stress draw the darn triangle. It's only going to help you solve these. So I'll do number 9. So in triangle DEF, so here we go. Here we have a triangle. We'll do D, E, F. It says angle D is equal to or congruent to angle. So I'm going to put the markings of congruency. Those two guys are equal. So just right off the back, because we're working with isosceles, if those two guys are equal, that means that this side and this side are equal. So DE is x plus 4. EF is 4x minus 8. Oh, my bad. EX plus 4. I've written on the wrong one. And then DF is 7x minus 35. All right. Find x and the measure of all sides. So I'm going to look at the drawing. So here I have these two angles right here that are equal. That means they're telling me that these two sides are equal. I know this side is measured 4x minus 8. I know this side is measured 7x minus 35. Because of the two markings, because of the converse of the isosceles theorem, these two are equal. So I can say 7x minus 35 equals 4x minus 8. Move the 4x by subtraction of both sides. 3x minus 35 is equal to negative 8. Then I'm going to move the 35 across by adding it. So that would give me, I believe, 27, if I'm correct. X equals 9. All right. They want the measure of each side, so I'm just going to substitute. X equals 9. Put that there. First one they want is D to E. So D to E is equal to X plus 4, which is really 9 plus 4. d to e is 13. Next one is e to f, which is 4x minus 8. So it's 4 times 9 minus 8. So e to f is 28. And the last one, df, 7x minus 35, which is 7 times 9 minus 35. Now, I'm only doing the work so that you see it is an isosceles, but I did not have to do this one, just so you know. They are equal. All right, here comes our last bit. Ask me questions tomorrow, please. Equilateral triangles. This is very important. A triangle is equilateral if and only if it is also equal angular. All sides are equal only if all angles are equal. That means that if all angles are equal, all angles equal 60 degrees. So if angle A equals angle B equals angle C, then that means all three sides, AB is equal to BC is equal to CA. And the opposite. If all three sides are equal, then all three angles are equal. Angle A, or the measure of angle A, is equal to the measure of angle B, is equal to the measure of angle C. All angles are 60 degrees in an equilateral triangle. So this kind of should be easy. Knowing this about an equilateral triangle, this guy's easy. If two of them are 60, then that means the third one has to be 60 degrees. If all three are equal, then all sides are equal. 9, 9. In this case, it's telling you simply by the marks, okay? Those are equal, those are equal, those are equal. If that's the case, then each one of these angles has to be 60 degrees. Because if I add all of them, they equal 180. So let's inject algebra into this. It is stating this is an equilateral triangle. Solve for x and y. Well, I'm going to do the easiest one first. It's telling me it's equilateral, then I know each one of these is 60 degrees. So I'm going to solve for x first. Super easy. Those two are equal. That means that 7x minus 3 has to equal 60 degrees. 7x. If I move the minus 3 across, 63. X equals 9. All right, the next one, solving for y. Keyword equilateral. All sides are equal. So pick and choose who you want to do. You only need 2 of those. I'm going to go with, let's go with 14y minus 59 equals 9y plus 1. Whichever 2. It doesn't matter. All right, so I'm going to move the 59. Actually, let's move the 9 across. I'm going to move the 9 across. I'm going to be left with 5y minus 59 is equal to 1. Move the 59 across by adding it to both sides, and I get 60. That means y has to be 12. And that's how you do that. All right, let's see what problems you're going to do. I think I'll give you 6 today. Let's work on 1, 3 for your homework. Let's work on 6, 8, 11. That's 1, 2, 3, 4, 5. Ooh. 14. That is it for you. All right, hopefully you understood, and I will go over this tomorrow.